All right, let's get started here into section 4.1, factors and monomials. Mono meaning one, and we're going to look at expressions that have a single term to them, right? Remember, terms are separated by addition and subtraction signs. All right, in chapter 4, there's probably going to be a lot of new concepts that you haven't done before, so you have to make sure that you're following along and seek to understand, and don't expect to just pop in right away. So don't get frustrated, just continue at it. Keep working to understand and ask questions if you have them along the way. Our learning targets are going to be to determine if a number is a factor of one another, and determine if an expression is a monomial. Now, factoring is going to be something that comes up again in algebra, and you'll hit it harder. So knowing the basics and understanding what you're doing when you factor is going to be important. So factors are numbers that can divide into one another evenly. All right. For example, if I take the number 20, the factors of 20 are 1, 2, 4, 5, 10, and 20. And that's because they all divide in evenly. 3 is not a factor of 20 because it does not divide in evenly. And so these are all of the factors of 20, right? And they come in pairs, right? 1 times 20 is 20, 2 times 10, and 4 times 5. We'll start by looking at the divisibility rules, and you may or may not have gotten to these in sixth grade. So this could be a review for some of you. In divisibility rules, just tell us if a number 2, 3, 5, 6, or 10 divides in to a number by different rules, right? Obviously, if a number is even, or if the ones digit is divisible by 2, then the whole number is divisible by 2. For 3, if the sum of the digits is divisible by 3, then the whole number is divisible by 3. For example, if I take the number, let's say 54. Since 5 and 4 are divisible, 5 plus 4 is 9, and 9 is divisible by 3, then 54 is also divisible by 3. If I take the number 71, right? 7 plus 1 is 8, and 8 is not divisible by 3, so I know that 71 would not be divisible by 3. It's divisible by 5 if the ones digit is either a 0 or a 5. And then it's divisible by 6 if it's divisible by both 2 and 3. Not one or the other. It has to be divisible by both 2 and 3. That would mean it's divisible by 6. And if the ones digit is 0, then it's divisible by 10. So we'll just look and see using the divisibility rules. So we'll say why or why not. So it says, is it divisible by 2, 3, 5, 6, or 10? And we're looking at the number 138. So it is divisible by 2 because 8 is divisible by 2. The ones digit. So 8 is divisible by 2. So I got to test out 1 plus 3 plus 8. 1 plus 3 plus 8 is 12. Is 12 divisible by 3? Yes. So 138 is going to be divisible by 3 because sum of the digits is divisible by 3. Is it divisible by 5? No. One digit, at the one spot, the 8 is not 0 or 5. Is it divisible by 6? And I can say yes, because it's divisible by 2 and 3. So that means that 6 will go into 138 evenly. Is it divisible by 10? No. The ones digit is not a 0. So those are using the divisibility rules just to determine, is it divisible by one of those 5 numbers? All right, finding factors of a number. All right, so when we find factors, we want to find numbers that divide in evenly. And in order to do that, we just take the number that we're looking at. In this case, it's going to be 72. And we're going to just divide and see if it divides in evenly. All right. And if you divide in evenly, it has a pair, meaning that is 72 divisible by 1? And the answer is yes. And what are the factor pairs? It's 1 and 72, right? Because 1 times 72 gives me 72. So I can go on, is 72 divisible by 2? And I'd say yes, right? And the pair would be 2 and 36. Is 72 divisible by 3? Say yes. 72 divided by 3 is 24. 72 divided by 4. Yes, it is 4 and 18, right? And you don't have to know these off the top of your head. You can just take your calculator and start dividing it. So if you don't have a calculator, a good online calculator is desmos.com. So desmos.com. And you can just launch graphing calculator. And so over here, you can just type in 72 divided by 4, and it'll tell you your answer. So 4 and 18. And I can space that out of there, and I can go 72 divided by 5. 5 is not a factor because it doesn't go in evenly. It has this decimal part. So then I can go on 72 divided by 6. So if we go back here, we can say no, right? We don't need a pair there. We said yes, 72 divided by 6 is 12, so 6 and 12 would be the pair. I can try 72 divided by 7. It's a decimal, so no. 72 divided by 8. I can say yes. Right, we didn't need one there. And it's 8 and 9. And now I would go and do 9. I could say yes, but that's going to be 9 and 8. So I have a repeat. So essentially, as soon as you have a repeating factor, right, I have 9. I got to 9, so this is a repeat. That means all of these factors up here are all the factors I have. So that's how I know that I have them all, as soon as I get a repeat factor pair. So if I were going to list them all out, I would list them 1, 2, 3, 4, 6, 8. So I went down all here. And then I'm going to go back up this side. So then I have 9, 12, 18, 24, 36. Hey guys. Sorry, family's just coming home. All right, so these are all of the factors of 72. All right, our next concept is determining if an expression is a monomial, meaning a single term. So we have some examples over here, right? The number 4, that's a single term. Any number by itself is a single term. A variable by itself is also a monomial. Um, you could have a combination, right? I could have y, I could have x, y, z, right? That would be a monomial. The product or the combination of a number and variable or variables, right? Negative 3xy or 6z or 7abc. Those are all monomials, meaning it can't have a plus or a minus separating the terms, such as 2 plus x. That is not a monomial. That has two terms. 5c minus 6 has two terms. Notice in the monomial, the negative out front is fine. It's not separating the terms. Here, if I were to distribute that out, I would have 3a plus 3b. That is not a monomial. However, if I have 3a and then I have negative 7b, this is a monomial because I can multiply this and get negative 21 AB, right? Single term. There's no plus or minus separating them after we do multiplication. All right, and we'll look at some examples of those as well. So I'd like you to pause the video here and use the divisibility rules to determine whether each number is divisible by 2, 3, 5, 6, or 10, right? For example, if I go through the checklist, 51 is not even, so it's not divisible by 2. 5 plus 1 is 6. 6 is divisible by 3, so I know that that works. The ones digit is not a 5 or a 0, so 5 doesn't work. Has to be both 2 and 3 in order for 6 to work, so that's a no. And it's not ending in a 0, so 10 doesn't work. So 3 is the only one that is 51 is divisible by. So go through and check using those rules for 2, 3, and 4. All right, so if we look here, 146 is divisible by 2 and not 3, 5, 6, or 10. Number 3 was divisible by 2, 3, and 6. And number 4 was divisible by 2, 5, and 10. All right, now we're going to get into listing all the factors for a given number. And we're going to start with 80. All right, and you can see that I have my paper set up here. And I would write these down in your notes. If you want to write down the divisibility rules in your notes, do that as well. But the factors, I've just listed 1 to 14. Typically, in the numbers that we look at, by the time you get to 14, you'll have a repeat and you can stop. But I just start with 1 to 14, and we may have to go over that. So, but that's just a starter. If you want to do 1 to 10, you can do 1 to 10. Obviously, 1 is always a factor because 1 divides into everything, and it's 1 times 80, right? I can do 80 divided by 2, and I get 40. I can try 80 divided by 3, but it's going to give me a decimal, so that's not a factor. 80 divided by 4, I get 20. 80 divided by 5, I get 16. 80 divided by 6 gives me a decimal. 80 divided by 7 also gives me a decimal. 80 divided by 8, that's 10. 80 divided by 9 does not go in. 10's a repeat, right? I would just be listing them in reverse order. So I can stop here. I don't need to go any further. So these are all my factors. Now, I'm fine with you just leaving them like this. Note the answer key will put them in order. It'll say 1, 2, 4, 5, 8, 10, 16, 20, 40, 80. So just know that that's what the answer key will look like. If you just have them listed here and you go through and check, you just check them off as you go. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I only got to 12 that time, which is fine. But I want you to go through and see if you can list all the factors for 2, 3, and 4. So pause the video here and list all the factors for 2, 3, and 4. All right, let's see how you did there. For 75, would have gotten 1 and 75, 3 and 25, and 5 times 15. So the set of factors would be 1, 3, 5, 15, 25, and 75. Number 58, we ended up having to go all the way up to number 29 if we were listing them out, right? And our factors ended up being 1 times 58, 2 times 29. So here's your set. For 203, same thing, ended up having to go up to 29. It was 1 times 203 and 7 times 29 are the only factors to get you to 203. So to find factors, right, all you do is you divide each number, right? So for number 4, I started at 1. I always know 1 goes in there. 203 divided by 2 was a decimal. Divided by 3 was a decimal. Divided by 4 was a decimal. Divided by 5, 6, all decimals until I got to 7, right? I knew 7 times 29. And then I did 203 divided by 8 all the way up until 28. Those were all decimals. And then I knew 29 was a repeat, so that I knew I was done. And that's how I list all the factors of those numbers. All right, determine if the expression is a monomial. All right, so I want you to go through and pause the video here and just give me a yes or no, whether you think that's a monomial. And then we'll check them and we'll talk about why they are or they are not. So pause the video here and do 1 through 8. All right, let's see how you did here. Number 1, yes, it's just a variable. That's one term. Number 2, yes, that's one term. It's just a number. Number 3 is no, because they're separated by the plus sign. That gives me a term of S and a term of T. Number 4, yes, that is a monomial because these are all tied together with multiplication. It's negative 3xyz. That's one single term. Number 5 is not because it's separated by this plus sign. So I have this term of 3c and a positive 5. Now, here's where it gets sometimes confusing. This is 8x times negative 3y, and I can always multiply the numbers together, right? So I could say 8 times negative 3 is negative 24, and then I have an x and a y. So this is a single term after I simplify it. So yes, that's a monomial. However, here when I distribute, there's 2 terms in here, so after I multiply, there will also be 2 terms. So this would be 12t plus 12, and there's 2 separate terms, a variable term and a number term. So no, that's not a monomial. Here, this is 10 times negative t, which is negative 10t. So yes, that is a monomial. Right, so here I have a single term times a single term. I get one term out of that. Here I have a single term, the 4, but I'm multiplying by 2 different terms, meaning I'll get 2 different terms. So that's how you determine if it's a monomial or not. All right, I'd like you to work on section 4.1